The topic that I would like to discuss today is assessing multimodal freight corridor bottlenecks. This is an application of CUBE to the Eastern Economic Corridor, or EEZ, in Thailand. My name is Dr. Sarawut Jansuwan. Currently, I'm Assistant Professor and Associate Dean for Administrative Affairs, Department of Logistic Management, National Institute of Development Administration, or NIDA, in Thailand. So what is a EEC? I would like to just give you a background that EEC is the projects that the government would like to boost the Thailand economy by developing the infrastructures and develop the cities, the areas. The EEC, as you can see in the picture, this is the Bangkok area. The EEC is the area in the eastern part of Thailand, including 3 provinces. Chonburi, Cheongsao, and Rayong. So these 3 provinces is the major key area that already has the industrial development long time ago, 30 years. So, however, the government also would like to boost up this area by including many infrastructures. Like, say, for example, they want to expand the Lam Chabang port here, which is a major port in Thailand. So we also want to expand the railway track that connect with the 3 airports. This is a high-speed rail that we would like to construct in the futures, and also the double track that we would like to connect the 3 major ports. Okay, so this is the idea that the government would like to invest. Okay, so in our study, we would like to also see what is the bottlenecks, what is the network capacity of this area. So in that case, we can have the idea how we can invest, the location we should invest. And this is the multimodal networks that we consider for the whole area. So this is the project, okay, that I'm talking about. This is the several projects related to transportation infrastructure, including Utapao International Airport. This is the airport, the new airport that built based on the current one that already has, but we want to expand the capacity of the airport. We're gonna build the Mataput port, Lam Chabang port. This is 2 major airports in the eastern part of Thailand. High-speed rail, okay, and you can see authors, like, say, for example, they want to build industrial tourism, new city hospitals, motorways, and also the dual-track railways. So this is a bunch of projects that they want to invest in this in EEZ areas. So what we want to do here, we want to share with you our works that we already have finished for the DOH projects. So the work that we have done is that we would like to assess the network capacity of the Eastern Economic Corridor, or EEC, and with this model, we want to identify, okay, the potential location of the bottlenecks in the area. And the bottlenecks or the choke point in the area is very important because we want to see whether, like, where is the location of the bottlenecks that we would like to expand the capacity of the bottlenecks or the potential of bottleneck in such a way that they can increase the capacity of the network, especially in the EEC areas. So we would like to use these frameworks to further apply, okay, for further help the planner to increase or improve their multimodal network capacity, and they can derive the policy that can improve, okay, overall capacity of the networks. So I just want to briefly explain what is the framework here. The technique that we use, we call network capacity flexibility model. Okay, so what is the capacity flexibility model? We would like to explain using this 2 simple flowchart. Okay, the network capacity flexibility model is has been framed and been developed as a bi-level network capacity model. So if we think about bi-level network capacity model, we have the upper level and lower level. Okay, so the upper level itself, okay, is like the planner view, point of view, that they would like to feel the demand, okay, in the networks in such a way that the lower level is the road user behaviors. So when we increase the demand, okay, in the network, okay, so you can see that how the road users interact with this the demand that they feel, okay, and we gradually increase the demand, okay, and you see that this is the interactive between the planners and the road users. When we increase that, okay, in the such to the such level that it will reach to the capacity of the network, okay, so when it reaches to the capacity of the link that in the networks, so we can see that, okay, what is the capacity of the network that we have. So we call this as the bi-level capacity model. And you can see in the picture here that if you have a planner, right, so you have OD pairs, OD matrix. So we would like to increase that using the base pattern that we have, the OD matrix that we have. We gradually increase that. And when we increase that, of course, the road user will interact and react to that congestion that may increase because of the demand increase, right? So in that case, after it's reached to the equilibrium point, it means that we can have we can know that, but it's the network capacity that they have in its model. Okay, give you more example of these pictures. This picture give you an example of the analogy of the reserve capacity or spare capacity that we're talking about. Actually, the network capacity flexibility is not the new model. It's the original proposed by Wong and Yang in 1997 already. So as can be seen in the pictures, okay. So if we have this, it's like a bucket, okay, and then we have the inlet here, so we can input the demand. It's like water that input in here, okay, and we can know that if we can still input the demand in this bucket, okay, the demand, okay, will be increased until it reach, okay, the room here, okay, we call as a reserve capacity. Okay, this is the capacity. So the mu here is the capacity multiplier, okay, to assess whether like the existing network, did they have reserve capacity or not. Okay, this is the upper and lower level that I'm talking about. The upper level is like we want to maximize the multiplier here. So we want to see, okay, what is the maximized multiplier that the network can be accommodated. And the lower level itself is a traffic assignment problem or user equilibrium problem. Okay, so this is the idea behind of the model, the capacity flexibility model. We would like to use this idea, okay, to assess, okay, the capacity, the reserve capacity of EEC network, the multimodal networks. Okay, so in that case, we can assess whether like, okay, with the current networks, do they have reserve capacity or they don't have reserve capacity? Or, and if we invest, okay, in terms of infrastructures in the multimodal networks, so they can help the network to improve, to increase the reserve capacity or not. This is our goal of this research work. And this is the formulation behind the network spare capacity. And this is for the single model. Okay, I would not go to details on this, but just let you guys have an idea that we have upper level here and lower level here. Okay, the upper level, we're talking about how to maximize the mu. Okay, this is the multiplier of the OD demand matrix. And of course, the constraint here is the link capacity constraint. Okay, so we cannot assign the volume, the multiplier higher than the link capacity. Okay, so for the lower level, we're gonna have the traffic assignment, which is the user equilibrium. Okay, so in the cube, so you can remember this is the combined in the cube application. So you can see that this is the lower level. Okay, so this is the constraint for the lower level. So I will not go to the details, but this is the work interactively until they reach to equilibrium for the both upper and lower level. Okay, so the outcome or the output of this bi-level is that we're going to have like mu, which is the demand multiplier, which will tell us whether like the current network they have the spare capacity or not. Let me go back a little bit, and you can see here. Okay, after we run that formulation, we can have like, okay, whether like the capacity multiplier of existing model is that over than 100 or is lower than 100%. If it's lower than 100%, which means that this network is currently don't have any reserve capacity. Okay, but if it's over than 100, which means that the mu is like represent that the current network that still have the reserve capacity. Okay, I will show you the result later. What is the current situation, okay, of the multimodal networks of the EEC. And I just want to go a little bit deeper. If you want to go to the multimodal, the previous one we're talking about the single modal, okay, which is considered only the passenger. But of course, in the EEC, okay, we consider both passengers and freight transportation. So the freight transportation mostly they can go by highways or railways, right? So in that case, we want to accommodate for not only the single modal, but we would like to address for multimodals. So we need to modify that upper and lower level as well. Okay, so the objective function here is still demand multiplier for the OD. Okay, so this is the freight and the passengers. Okay, so this is the mu that we can use for the demand. And of course, we need to modify the constraints. So the constraint will be like a highway link capacity. And of course, if you have a railway, you should have a railway link capacity as well. Okay, so we need to have the total production constraint, total attraction constraint, which is combined between highway and railways. Okay, and the non-negativity constraint as well. So this is the upper level. It's a little bit more complicated from the single to the multimodal. But of course, it's even more complicated for the lower level, but give you an idea that this is the modifier of the user equilibrium that they can address for multimodal. And you can see this, this is the, if you can look at the Sheffield book, this is the Bible for the network analysis, right? So you can see that this is the very simple user equilibrium for multimodal that we adopt from Sheffield. And the constraint will be also modified. Let's say, for example, the constraint here, we need to multiply with the mu, okay? And the truck and rail, OD flow, okay? The path flow for the truck, the link flow, okay? And this is non-negativity constraint again. So this is to just give you an idea that behind, okay, the framework, we need to modify the formulation in such a way that they can capture not only the single, but also the multimodal as well. And how we can implement this in Cube. So we can think about that this is the very typical four-step model, okay, but we need to have the multimodal network, okay, we need to have the 4 steps, okay, and we should have the of course step generation, distribution, mode choice, assignment. And in this final step, we need to have the checking condition whether like the link capacity is the reach to the capacity yet. Okay, if it's not, okay, we can multiply by increase the multiplier mu, okay, by gradually increase by small mu, okay, to the OD matrix, and then we reassign it again, okay, until it reached to the link capacity. When it reached to the link capacity, Okay, we know that, but it's the maximum mu, okay, that we have. So this is the capacity multiplier for the multimodal network capacity model. This is can implement within the Q frameworks, right? So we can loop it within the Q frameworks, and then we can identify, okay, what is the mu that is the maximum that we can have for the current networks. So for this all input, okay, we also assess the multipliers of the current demand, okay, for the current networks, okay, current networks based on the existing infrastructures. And we can see that for the base case result, the current demand, they give us the mu as 0.83, okay, 0.83, which is already mean that is less than 1. What does it mean? If it's mu on multiplier less than 1, which means that the network has no reserve capacity at all. Okay, so which already indicate that, okay, there's a bunch of location that's already congested. Okay, for this, you can see that the location as can be the potential bottleneck. Okay. You can see that the location that I try to point out is in the red one here. Okay, it's the kind of potential bottlenecks. Okay, and there are few location. Okay, it's a potential of the future bottleneck, which is in this, okay, route. Let's say, for example, route 331 here. Okay, it's going to be yellow, but others here that I try to highlight here is already red, which is the congested. Okay, so we also want to see what is the impact, what is the effect of the highway development plan. So we try to input, okay, different development plan. Okay, so I try to use the highway, okay, phase 1 and phase 2. So this is, sorry, that's in time, but this is the expansion project, okay, that we want to expand the capacity of the highway in different routes. Okay, and this is the first phase in the green one, and the yellow one, orange one, this is the second phase. Okay, so you can see that after we increase the capacity by using the investment of the government, okay, what is the reserve capacity that we have, okay, for the multimodal networks? And you can see that when we put the first phase in, the mu, remember the previous one, okay, the mu is 0.83, okay, but when we invest or construct the highway projects for the phase 1, so the network capacity is increased, and you can see that the mu here is 1.01, okay, compared to the previous one. The network capacity increased by 28%, and you can see that with that assessment, we can also know that with the current highway development project can help to improve the network capacity almost 30%. Okay, so, and in the same time, we also can identify the location, where is the potential bottleneck location. I think the location of the bottleneck is still the same here, which is route 34, okay, and route number 7. But interestingly, you can see that route number 3 and route 331, okay, that previously get yellow is getting better. Okay, so you can see that it can help to improve this, okay, with the projects here, so it can improve that bottlenecks or choke point along this EEC area. Okay, of course, this two still has the potential, but is there still are the potential bottlenecks for this area. But these two, okay, they kind of relieve, and then they can improve. Okay, and later we also try to put the second phase in. Okay, and you can see that for the second phase, the mu increased about 30%. Okay, so this is the mu. Okay, and interestingly, when we increase the mu, so you can see that we can locate another potential bottlenecks in here. So here is going to be green, right? And 7 is already green, okay? But the bottleneck is moving to this root number 3, okay? So we can see that with this framework, we can also assess the capacity of the network as well as the potential bottlenecks, okay? That may occur or happen in the future. And this is the conclusion of the reserve capacity, okay? And you can see that with the present situation, we don't have the reserve capacity at all, okay? But when we invest in highways networks, so we can increase the capacity, and as we can see that the OD multiplier is improved from 1.01 to 1.16, okay? So in that case, there is a progress in terms of the investment. If you remember, we want to also further assess the multimodal networks. So in that case, we need to using not only the highways, but also use the railway projects. Okay, we include that railway projects in the networks, and then we try to using the same frameworks, and then we assess the capacity again. And you can see that, okay, with the existing condition, if we consider both transportation multimodal networks, we can see that the current condition, okay, we can have spare capacity about 1.17. Okay, remember, if we consider only the highways, we see that we don't have the enough capacity already. But if we consider both bimodal networks, including highways and railways, we can see that the capacity of the network is improved. Okay, and with the projects, okay, with the highway projects that they include, and also the railway projects, they can improve the multiplier is increased from 1.17 to 1.47 and 1.55. Okay, respectively. So you can see that with these frameworks, okay, we can also assess the capacity of the networks, and also we can test the sensitivity and see whether, like, if we increase the mu, okay, 10%, 20%, where are the location of the bottleneck and the choke points in the area. So because we try to input the demand, okay, by gradually input 10%, 20%, and we can see that, okay, where is location of the bottlenecks in the networks, okay. So that's about our works that we done. So okay, so hope you hope this frameworks will be useful for you. And this is concluding remarks for our works. Okay, so with this framework, we develop a capacity flexibility model, okay, to assess the multimodal network capacity, and we use the EEC of Thailand, okay, to assess the flexibility and see whether, like, where is the potential bottlenecks in that networks, okay, and how we should invest in such a way that they can improve the overall network capacity. So this is very useful for many applications. Let's say, for example, we can use this as the infrastructure planning policy, okay, to help the DOH planner or transportation planner, okay, to plan better where we should locate the infrastructure in such a way that they can improve the bottlenecks, and they can also increase the capacity of the network. Of course, all of this, okay, can be integrated to the cube model, and we can automatically work with the cube and then to identify the potential bottleneck using our frameworks. Okay, in the future, maybe we can develop another multiplier which is already there, but I'm still not connected to the cube yet. We call it as an ultimate multiplier. So in the previous, the current one that we're talking about, we uniformly increase the multiplier, right? So in the future, we think that the multiplier for each OD player can be increased non-uniformly, Okay, so in that case, we can see what is the ultimate capacity of the multimodal networks. Okay, so hope you guys get what I try to convey for this research, and I think that may be useful idea and very good to share with you guys. And this is the team that we work. It's not only me, okay, but also our team that we work, including faculties. This is my senior. This is my professor from different university in Thailand. Thank you very much.